Welcome back. We are still on lesson 2, giving the models a chance. This is activity 2.2, where we're going to be constructing and interpreting answering questions using a probability model. Let's get started. Number 1, it says construct a probability model for each situation. Explain how you constructed the model. Then determine whether or not the probability model is a uniform probability model. Remember that vocabulary word is on the previous page. Uniform probability model. So part A, it says rolling an 8-sided polyhedron with the numbers 1 through 8. Now, if you don't know what a polyhedron is and you've never seen one, this kind of gives you a hint off to the side right here. It says an 8-sided polyhedron is a 6-sided number cube, but instead, or is like a 6-sided number cube, but instead it has 8 sides. And it looks like this cube right here in the middle. Unsure if we can really call it a cube, but it looks like this one with an 8 on it, where you've got 8 different triangles. I wish I had one in real life to show you so you could roll it, touch it, feel it, but this is going to have to do for now. Alrighty, so I'm going to first model how you would set up a probability table on your own, answer this question in its entirety, and then after I've given you a model, I'm going to release you to answer questions B, C, D, and yes, that's it. B, C, and D. All right, so let's look at this 8-sided polyhedron with numbers 1 through 8. So our outcomes are going to be listed on the top. So our outcomes, I know if I've got an 8-sided die, I know I could roll a 1, I could roll a 2, I could roll a 3, a 4, a 5, 6, 7, and 8. And if you're not already, please take these notes along with me so that you are not left behind when you have to do it on your own. So if I've got an 8-sided die, those are my outcomes. Now, I know that they are all how do I say this without giving the answer? I'm thinking through my problem. I'm thinking about a die. Are they all the same size, or are there bigger size than the other? Are there more numbers that are going to show up than the other? Probably not. So I know if I were to roll a 8-sided polyhedron die, I know my chances or the probability of rolling a 1 is 1 out of 8. Same with a 2. How many 2s are on this die? Well, there's only 1 2 out of 8. How many 3s are there? There's only 1. How many 4s? 1. How many 5s? 1. Look how easy this is. This is pretty easy. There's only 1 6, there's only 1 7, and there's only 1 8. And notice I am putting them all out of 8 because in total there are 8 outcomes. Also, one more way I can check this is by adding all of these up and determining if they in fact equal one whole. And if I have 8/8, then yes, that in fact does equal one whole. So I know that is correct. Now, I'm going to continue answering this question. So I constructed the probability model. That was the first thing. Now I'm going to explain how I constructed the model. Well, I explained it as I constructed it. So as you're constructing them, make sure you're explaining with your partner or explaining to yourself out loud. And then you're determining whether or not it is a uniform probability model. Now let's go and remind ourselves what a uniform probability model is. A uniform probability model is when all the probabilities in a model are equally likely to occur, meaning they have the same chance or same probability. So looking at this, I can see that they, yes, are all the same. So yes, this is uniform. Yes, this is a uniform probability model because, and also you can explain and take it up a notch, because they all have the same chance of being selected. Try to be detailed in your explanation. That's how you know that you are a true master of this skill. Alrighty, now that you've got a model and you've got something to go off of, I'm now going to release you to do B, C, and D. B says, choosing a marble from a bag of marbles containing 1 green, 2 red, and 7 blue marbles. And I want you to be successful so bad, I went ahead and drew you a picture with color. You're welcome. C says, selecting a member of the chess club whose members are Samuel, Martha, Carol, John, Sally, Ronaldo, and Simon. D says, oh, and I'm not going to draw all of those. You can figure that out on your own, what those outcomes should look like. And D says, selecting a member of the chess club with a 3-syllable name out of Carrington, Martha, Carol, Joanne, Sally, Ronaldo, and Samantha. So, and I did that on purpose to help you, because if you don't know what a syllable is, remember a syllable is, I'm not an English teacher, but the way you would count syllables is every time that you, I guess, have to pause. This is hard to explain. For me, I'm a math teacher, but for example, Carrington. Carrington. I just clapped 3 times because that's how many syllables are in the name Carrington. Even Ronaldo and Samantha. So you're figuring out the probability of choosing a chess club member with 3-syllable names and the ones that don't have 3-syllable names. All right, I'm going to pause here. I want you to pause here. I'm going to leave it here. That way you've got this model for you. I want you to set your timer for 4 minutes max, 4 minutes to complete B, C, and D. Pause here. Alrighty, now that you've had time to work, let's review our answers. So for B, you should have put in your outcome row G, R, and B for green, red, and blue. Of course, you could have spelled them out. For green, the probability is 1 out of 10. For red, the probability is 2 out of 10. And for blue, it is 7 out of 10. And it's real easy because it tells you the exact number in the description. Now, is this a uniform model? No, it is not. All of these probabilities are not the same. So what do we call that? We call that a non-uniform model. Moving forward, for C, selecting a member of the chess club. So say I put all of these names in a hat and I mixed them all up. Well, what would be the chances that I select Sam, Martha, Carol B, John, Sally, Ronaldo, and Simon? Well, they all have an equal chance because there is only one of them and their name is only in the hat one time. So I know that Sam has a 1 out of 7 chance. Martha, the same thing. She has a 1 out of 7 chance. Carol, a 1 out of 7 chance, and so forth. So is this a uniform model? Yes, this is a uniform model. All of the probabilities are the same. And also, I just thought of something too. If it's hard for you to understand why it's called a uniform model, think about what a uniform is, a military uniform or a school uniform. What do you notice about those? Well, they all look the same. So if all of the probabilities are the same, it is uniform. All right, let's continue. D, it says selecting a member of the chess club with a 3-syllable name. So I underlined my 3-syllable name, which was Carrington, Ronaldo, and Samantha. There were 3 of them. And then I circled my names with 2 syllables: Martha, Carol, Joanne, Sally. There are 4 of them. So I know 4 plus 3 gave me a total of 7. My 3-syllable names, there's a 3 out of 7 chance that I pick one of them. And my 2-syllable names, there's a 4 out of 7 chance. Are these probabilities the same? Are they equally likely? No. So we call this a non-uniform model. Alrighty, now that we've got a good grasp on what a uniform and non-uniform model is, and we know how to create one, let's move on to question number 2. To sum up this activity, it says, use the probability model to calculate each probability. So you're going to answer below. A, what is the probability of the outcome being a 3? B, what is the probability of the outcome being an 8? C, what is the probability of a number less than 8 being selected? And D, what is the probability of it being a prime number? And remember, a prime number, I'm going to give you an example, is any number that can only be divided by 1 and itself. For example, the number 3. I can only multiply 3 and 1 to get 3. I can't divide it by 2. I can't divide it by any other number. That's it. It only has two factors. So that is a prime number. Just an example, but there are more prime numbers in this table here. Alrighty, you're going to do this on your own. Set a timer for 3 minutes max because it really shouldn't take you that long. 3 minutes max to complete the probability for A through D. Pause here. Alrighty, let's compare our answers. So the probability of rolling a 3, as you can see in orange, I circled where the outcome was 3. That probability is 3/12. So that information I was able to take straight from the table. And 3/12 simplifies to be 1/4 if we divide the top and bottom by 3. Now, simplifying is also important here because in your practice, you will have to find the probability in simplest forms. So always ask yourself, can this fraction be simplified? For B, the probability of rolling in 8, we got 0 out of 12. Well, why is that? Do we see an 8 as an outcome option? No, we do not. So we know that there is no chance that that can be rolled. So 0 out of 12 is equal to 0% or 0. For C, what is the probability of choosing a number less than 8? Well, look at all of those outcomes. Is 2 less than 8? 3, 4, 5, 6, 7. All of them are less than 8. So I know that 12 out of 12 is the probability for choosing a number less than 8, which simplifies to be 1 whole. And then for D, the probability of choosing a prime number. What I did was I circled those prime numbers in that dark purple color. So I circled 2, that's a prime number because I can only divide and get 2 and 1. 3 is a prime number. I showed you why. 5 is a prime number. Its only factors are 5 and 1. And 7 is a prime number because its only factors are 7 and 1. So I took all of those probabilities of each of those and I added them together to find the total probability. So 2 had an outcome of 1 out of 12. 3 had an outcome of 3 out of 12. A probability. 4, the outcome had a probability of 1 out of 12. Oh, sorry, I'm reading too fast. 5 had a probability of 5 out of 12, and 7 had a probability of 1 out of 12. When I added those together, I got 10 out of 12, which can be simplified to be 5 out of 6. And lastly, I know I didn't see this one, but E, also you should have answered, what is the probability of selecting an even number? The same exact thing in green. And I love color coding so that you guys can see my notes and what I'm doing and explanations even easier. So notice my even numbers, I put an E, a green E next to it. So 2, 4, and 6 are my even numbers. So then I added 1/12, 1/12, and 1/12 to get 3/12, which also can be simplified, and it simplifies to be 1/4. Alrighty, take a second to get these notes down if you need. But that concludes this activity. You just learned how to answer or set up a probability model and answer questions and find probability using a probability model. Alrighty, I will see you in the next video.